Okay. Now we'll see the application of the application of Nernst equation to equilibrium constant. Suppose I have a reaction going on in which my system has attained equilibrium. Say for example, I have A plus B gives C. Now we know in any spontaneous reaction my delta G is negative. In any non-spontaneous reaction my delta G is positive. That means if A plus B is spontaneously forming C, so for that reaction my delta G will be negative, and if A plus B is non-spontaneously forming C, so that will be my delta G greater than 0, and in that case backward reaction will be favored. But what if my equilibrium is achieved and the rate at which A plus B forms C is equal to the rate at which C forms A plus B. So that means there is no net forward reaction or net backward reaction. In that conditions, my delta G will be 0. So that means for equilibrium reactions, delta G becomes 0 at equilibrium. So that means I will get delta G is equals to delta G naught plus RT ln Q. This is 0. This comes here. So I will get delta G naught is equals to minus RT ln Q. Now since at equilibrium I told you my Q becomes K equilibrium. So I can write delta G naught is equals to minus RT ln K equilibrium. Delta G naught is what? Minus NF E naught. This equals to minus RT ln K equilibrium. Minus minus sign is cancelled. What I am left with is E naught is equals to RT by NF ln K equilibrium. Now I know I can replace ln by log by multiplying 2.303. And I know RT by F into 2.303 is what? 0.0591 by N log K equilibrium. So this is my equation relating equilibrium constant and my standard electrode potential. We'll see some examples from this. Questions have come from this part. So we have a question from NET December 2012 which says that the equilibrium constant for an electrochemical reaction. So this is December 2012. They have given the reaction 2Fe3 plus SN2 plus gives 2Fe2 plus SN4 plus. They have given the reduction potentials as E naught. Fe3 plus Fe2 plus is equals to 0.75 volts and E naught SN4 plus SN2 plus is equals to 0.15 volt. They have also told 2.303 RT by F is equals to 0.06 volts. So they have given all of these quantities and you are required to find the equilibrium constant. We know from this equation that E naught is equals to 0.06 by N log K equilibrium. I need N and E naught to find K equilibrium. Now, what will be my E naught? E naught is what? E naught cathode minus E naught anode. For that, I need to find which is my cathode and which is my anode. If you see carefully, Fe3 plus, which is at 3 oxidation state, is getting reduced to 2 oxidation state. That means from Fe3 to Fe2. That means this is my cathode. Here reduction is happening. So I directly write the reduction potential for iron, that is 0.75 volts, and which is the anode? Sn2 plus gets oxidized to Sn4 plus, that is minus 0.15. That will give me 0.6 volts. Now I need to find number of electrons taking place. So if you look at tin, 2 plus to 4 plus, that means 2 electrons are released. Now one Fe3 plus takes up 1 electron, another Fe3 plus takes up another electron. So my N is 2. If you have any difficulty in relating directly, you can write the two electrode reactions and then see for yourself. So I have got N, I have got E. Now I can simply put in this formula. I will get 0.6 is equals to 0.06 by 2. I have got log K equilibrium. Taking all of these to this side, I get 0.6 into 2 by 0.06 is equals to log K equilibrium. Now this gives me 110. So I am left with 20 is equals to log K equilibrium. Now in order to remove log, what do we put? We put 10 to the power something, whichever value is here. So I get 10 to the power 20 is equals to K equilibrium. This is my answer, which is the option number B. Okay, so these type of questions come from equilibrium constant. There are many more questions here. So one question came in December 2014. Again, it involves tin. So the question says that for the cell reaction Sn to Sn4 plus, we have this December 14. We have Sn plus Sn4 plus gives 2 Sn2 plus. And they have given the reduction potential in the form Sn4 plus 2 electrons gives Sn2 plus, and Sn2 plus 2 electrons gives Sn. The E naught for this is 0.15 volts and the E naught for this is minus 0.14 volt, and they have also given RT by F is equals to 25.7 millivolts. What do you need to find? You need to find ln of K. So now there will be a little change in the equation that we will use. So you see, if you just write this equation like this, Sn and Sn4 plus gives Sn2 plus Sn2 plus. Now you see, this Sn is oxidized while this Sn is reduced. So that means this is my anode, this is my cathode. Okay. So now I can find E naught cell. That will be what? E naught Sn4 plus to Sn2 plus. E naught cathode minus anode. Cathode is Sn4 plus to 2 plus minus E naught anode, which is what? From tin to tin 2 plus, but we have to write the reduction potential. So we write Sn2 plus to Sn. Now simply put the values. I would get, so this is my cathode, 0.15 minus 0.14, this would give me 0.29 volts. So now I'll put in the formula for E naught cell is equals to, so what formula we had? 2.303 RT by NF log Q. Now in this case, what is my log Q? This is my, okay, so that is equilibrium constant that we have to find. Now they want ln Q. So I will replace log by ln and I would get this as E naught cell is equals to RT by NF. 2.303 into log is what? Ln. and I have K equilibrium. Now RT by F they have given us 25.7 volts. So I get E naught cell is equals to 25.7 millivolt upon how many electrons? 2 electrons are involved. C Sn4 plus to Sn2 plus 2 electron change. Sn to Sn2 plus again 2 electron change. That means 2 electron change is there. And what is my LNK equilibrium? That is what we have to find. E cell is what? 0.29. So I get 0.29. I get 2 here. I have 25.7 millivolt. That means 10 power minus 3 volts is equals to ln K equilibrium. So volt and volt get cancelled. I am left with ln K equilibrium is equals to 0.29 by 25.7 into 10 power minus 3. That would give me something like 22.6, which is my option number A. Okay. Another question is there from net December 2013. This is again the question of equilibrium constant. Now the question says they have given you a cell. The cell is, this is 2013, right. The cell is zinc and I have zinc 2 plus. The concentration is 0.01. Then I have Fe 2 plus. Concentration is 0.001. And I have Fe3 plus, whose concentration is 0.01, and I have platinum electrode. They have given me E cell is equals to 1.71 volts. Now they are saying the equilibrium constant for the reaction. The reaction is zinc zinc plus 2 Fe3 plus. Reversible reaction gives zinc 2 plus 2 Fe2 plus. What would be the equilibrium constant for this reaction? Now, for this reaction, if we want the equilibrium constant, what do we need? E naught and we need N. N is easy to find. We need E naught. Now, how can we get E naught? We know from Nernst equation that E cell is equals to E naught cell minus 0.0591 by N log Q. We can easily find Q. We have the concentration of the ions. We know N. We know E cell. We can get E naught cell from here. So let's find it out. So I get E cell is how much? 1.71 volts. This gives me E naught cell minus 0.0591 by 2 log. So if you see this reaction, let us not directly go to the reaction. If I write the two half electrodes, I would get zinc producing zinc 2 plus 2 electrons and 2 Fe2 plus taking up 2 electrons. Sorry, it will not be 2 Fe2 plus. It will be 2 Fe3 plus taking up 2 electrons to produce 2 Fe2 plus. So the net cell reaction will have product as zinc and Fe, correct? So I can write, let this be Q, and my Q becomes concentration of zinc 2 plus into concentration of Fe2 plus whole square upon the concentration of Fe3 plus whole square. The concentration of zinc is removed because it is 1 as it is solid. So if I put the values, I would get zinc 2 plus is what? 0.1, that means 0.01. Iron 2 plus is what? 0.001, 0.001 square upon iron 3 plus is what? 0.01 square. Now, if I solve this, what would I get? I am solving this here. So, I would get 10 power minus 2, 10 power minus 3 square upon 10 power minus 2 square. That means I get 10 power minus 2, 10 power minus 6 and 10 power minus 4. Now see, minus 2 minus 6 is minus 8. This minus 4 goes up, becomes plus 4. So I have got minus 8 plus 4 is minus 4. So what I am left with is 10 power minus 4. I will directly put this here. So I get 1.71 volts is equals to E naught cell minus 0.0591 by 2 log 10 power minus 4. So now we'll solve this. On solving, we would get 1.71 is equals to E naught cell minus 0.0591 by 2 power minus 4 comes here. I am left with log 10. So I get E naught cell, this cancels, I am left with 2 here. So I get 0.0591 into 2, that gives me this, and log 10 is 1. So that is left. And I have 1.71 here. This goes this side, I get E naught cell is equals to 1.71 plus 0.1182. That would give me 1.8282. Correct? Okay. Now I need to find the equilibrium. So I will put in the formula, I would get E naught cell is equals to minus 0.0591 by n log K equilibrium. So I get log K equilibrium is equals to 1.8282. N is what? 2 electron exchange is happening, divided by negative of 0.0591. So on solving this, we would get some place I think I have made a mistake. Yeah. So here this was negative, negative becomes positive. So this becomes negative. I would get a different answer. So I have 8, 1, 9 and I get 5, 1.5918, and this will become 1.5918 with a positive sign only, 1.5918 into 2, and what else is, have I made any other mistake? What will be the last value? Yeah, I have made a mistake of taking this as negative. So this is positive, so this is positive. I will get this value like somewhere around, if this is 59, this is 159, almost like 28 or something. 28 to the 56. And what is the closest answer we have? The closest answer is so closest answer is 10 power 54. So the answer is 10 power 54, which is option number B. Okay. Now we'll see the application of Nernst equation to solubility product. Okay. So For a sparingly soluble salt, what do we have? Suppose we have a salt like this, AgCl solid giving Ag plus aqueous and Cl minus aqueous. So if we want to write the reaction quotient for this, that will be what? Concentration of Ag plus into concentration of Cl minus. So at this condition, upon AgCl. Now this is also the solubility product. So that means when we have a sparingly soluble salt, we can replace Q by Ksp. What will be the change happening in the? We get the Nernst equation as E naught cell is equals to 0.0591 by N, and I have log Ksp. This is 0.0591 by N. Okay, we'll see some questions from here. So this question came in GATE 2003, which says they are given the data of two half cells. AgCl plus electron gives Ag solid plus Cl minus aqueous. Then we have Ag plus electrons gives Ag solid. They are given the E naught for this as 0.22 and E naught for the second as 0.80 volts. What they are asking? They are asking for the solubility product of Ksp. Sorry, Ksp for AgCl. So I know AgCl will produce Ag plus Cl minus. So my motive is to get this as the net cell reaction from these two reactions. So how can I get that? Always see which is already present in my solubility product chemical reaction on the left side, that is AgCl. So what do we have? I have AgCl, so I will take the reaction which has AgCl on the left side. I get AgCl plus electrons producing Ag plus Cl minus. Now, AgCl plus electron gives Ag and Cl minus. Now I have to get Ag plus on the left side, but see there is no Ag plus here. But I have a reaction. If I reverse it and write, I would get Ag giving Ag plus electron. So what will be my net cell reaction? My net cell reaction will be Ag and Ag gets cancelled, electron get cancelled. I am left with AgCl giving Ag plus Cl minus. That means the equilibrium constant for this reaction will be my solubility product. Now I will write the Nernst equation for this, which says E naught cell is equals to 0.0591 . So this came in GATE 2004. This says the solubility product of silver sulfate at 298 Kelvin is 1 into 10 power minus 5. So that means Ksp is 1 into 10 power minus 5. If the standard reduction potential of the half cell, they have given one half cell whose reduction potential is 0.80. Let this be E naught Ag plus Ag. and they have asked the standard reduction potential of another half cell, which is plus 2 electrons gives Ag solid plus SO4 2 minus aqueous. Let the E naught be Ag2SO4 Ag. Okay. This might be wrong representation, but let us assume that it is this, and you have to find for this. Now, if you see the solubility, the dissociation reaction for Ag2SO4 is correct. Now, whenever we see the question of solubility product in electrochemistry, we have to arrive at this equation using these two equations. How can we do that? Suppose we have we have Ag2SO4 on the left side, and this equation has Ag2SO4 on the left side. So let's start with this. We will get Ag2SO4 plus 2 electrons gives 2 Ag solid plus SO4 2 minus SO4 2 minus ion. Now, if I have to arrive at this, I don't need Ag solid. What I need is Ag ion. So I will write this in the opposite fashion. So I will get 2 Ag gives 2 Ag plus 2 electrons. Now if I add the 2 Ag plus, so this remains as Ag plus 2 Ag, 2 Ag and 2 electrons are cancelled out. What I am left with? I have Ag2SO4 giving 2 Ag plus SO4 2 minus. Correct? Fine. So what do I get? If suppose this is my E naught cathode, and this is my E naught anode, and this is my E naught cell. Right? This is a cell reaction for these two electrodes. So I get E naught cell is equals to E naught cathode minus E naught anode. This is my formula. And E naught cell we know is equals to 0.0591 by n log Ksp. N is what? N is 2. 2 electrons change is happening. Fine. So I will just take into consideration this part. E naught cathode. They have not given, they have asked to find for this. That means I have to find for the cathode. I have for the anode. So I get E naught cathode minus anode is what? 0.80 volts. This is equals to 0.0591 by n into log 1 into 10 power minus 5. 1 into 10 power minus 5 means simple 10 power minus 5, and we know log for this means power will come in front. We are left with log 10, which is 1. So I get 0.0591 by 2 into minus 5. So to solve for this, so let's calculate. We'll get 55920 by 2. That would give me minus 0.14775. So I get E naught cathode minus 0.80 is equals to minus 0.14775. Now simply this will go this side, so I am left with E naught cathode is equals to 0.8 minus 0.14775. If you do the subtraction, you would get 522,570. 6. Yeah. So it is 0.65, which is my option number C. Okay. Then we have another question which came in GATE 2013. This says the standard half cell reduction potential of, they have given a half cell, this, the potential is minus 0.036 volts, and another half cell FeOH whole thrice, and Fe is equals to minus 0.786. They are asking the KSP of FeOH whole thrice. You have to find this, and you have to write the appropriate cell notation for finding KSP of FeOH whole thrice. That means in this question we have to find the net reaction for, if KSP of FeOH whole thrice we have to find, that means we have to find this net reaction from two half cells. These are the two half cells whose whose E is given. First we have to find the KSP, and we have to find the combination of these two cells so that we can get the KSP. So let us first write the reactions for these two. So that will be what? Fe 3 plus 3 electrons gives Fe, and in this case what is happening? So we have OH minus ions, we have FeOH whole thrice and Fe. So we will get FeOH whole thrice plus 3 electrons gives Fe plus 3 OH minus. Let us say we have these two and the reduction potentials are given. If we have to find the KSP of FeOH whole thrice, we have to write the dissociation reaction of FeOH whole thrice, which would be like this. Now that means using these two half cells we have to arrive here. So since FeOH whole thrice on the left side, we will use this equation which has FeOH whole thrice on the left side. So let us say my first equation is this. Fine. Now I need Fe3 plus, but I have Fe. I have need to remove Fe. This equation has Fe, but on the right side, so I'll just reverse it. I would get, now if you add the two, you will get this. So this becomes my cathode, this becomes my anode. So I need E naught cell. That will be E naught cathode minus E naught anode. And what would this give? This would be, so cathode is my FeOH whole thrice, that means this, it is this, negative of 0.786, and the anode is this, that means this one, that would give me minus of negative 0.036. If you solve it, you would get 0.750 with a negative sign in volts. I have got E naught cell. I can get KSP from here. So I know E naught cell is equals to 0.0591 by n log KSP. What is my n? N is my 3. That gives me negative of 0.750 is equals to 0.059 by 3 log KSP. Now, let us see the values they are given. Okay, so they had asked the EMF only. They have not asked for the KSP. They have asked only the EMF. That means I needed to find only this. So I have got E naught cell is equals to 0.750 with a negative sign. Now I also need to find the appropriate cell notation for these two half cells. That means this one and this one. So I have in the cathode, in the anode, Fe to Fe3 plus. That means my left side of the anode, left side of the cell notation will be Fe solid, and I have Fe3 plus aqueous. Then I will get salt bridge. Then I have this equation. First one. In this equation, FeOH whole thrice is dissociated to FeN3OH. Now the solid will be at the last. So I am writing solid here. Iron solid. This iron is not taking part in the redox reaction. So I will write it as OH minus here. Not the brackets. And we have FeOH whole thrice. So this is my cell notation, and this is my EMF for the EMF for the total cell, and that is the equation number B. So this is how you will solve if you are asked to find the cell notation and you are given two half cells and also the solubility product. So this has another question. The same question has another part which says the value of log E KSP. That means they are asking log base E KSP. Now log base E means ln. So I need to find ln KSP and for FeOH whole thrice. I will simply use the formula. E naught cell is equals to 0.0591 by n log KSP. Now there is a difference. The difference is that they have given the temperature to be 298 Kelvin. So I should not use 0.0591 because I need to find ln. Otherwise I would get log. So what I can do is I will write it as minus 0.750 is equals to RT by NF ln KSP. From here we can find ln KSP putting all the values, and that would be minus 87.8, which is the option D. Fine. We have one more question from this which came in net. Okay, so this question came in net 2015. It's a good question. So they are saying you have been given the E naught for Cl2 Cl minus as equals to 1.35 volts. Okay. Then you have KSP is equals to 10 power minus 10 for AgCl. And you have to find the E naught for the electrode of the reaction half Cl2 plus Ag plus electron gives what? AgCl. And they have also given 2.303 RT by F is equals to 0.06. You have to find the E naught for this cell reaction. So what will you do? We have been given the KSP. That means we have to make use of the dissociation reaction of silver chloride and arrive at that half electrode. So what do we have? So for the silver chloride, we know silver chloride gives silver ion plus chloride ion. We have E naught for this reaction, okay, whose E naught is 1.35 volt. Another reaction is half Cl2 plus Ag plus electron gives AgCl. Using these two, we have to arrive here. That means here AgCl is on the left side. On the right side, I will just inverse it. So I would get AgCl gives half Cl2 plus Ag plus electron. Right? Now from this I have to arrive at this. This has an extra thing. What is that extra thing? Half Cl2. I don't need half Cl2. If I just simply add the reaction, half Cl2 plus electron gives Cl minus, I can get rid of half Cl2 and the electron, and what I am left with is AgCl gives Ag plus Cl minus. That means this is E naught anode, this is E naught cathode, and this will give me E naught cell. Now from KSP I can get E naught cell. How? We have the equation so we have E naught cell is equals to 0.06 because they have given this as 0.06 upon n log KSP. KSP is they have given us 10 power minus 10, and log 10 power minus 10 will be what? Exponent comes in the front, so I am left with minus 10 log 10, and log 10 is 1, so I am left with minus 10 only. So E naught cell, I have to find E naught cell is equals to 0.06, n is what? 1, and I get here minus 10. So what do I get? Minus 0.6, so I get E naught cell is equals to negative of 0.6. Now E naught cell is made up of cathode and anode standard electrode potentials. So I will write E naught cathode minus E naught anode, that should give me negative 0.6. So I was given the electrode potential for the cathode, this one cathode, and I have to find for the anode. So if the cathode react is 1.35, so I get 1.35 minus E naught anode is equals to negative 0.6. So E naught anode goes here, 0.6 here, so I get 1.35 plus 0.6 is equals to E naught anode. That would give me E naught anode is equals to 1.95 volts, which is the option number D. There is another question which came in, I think, GATE. No, it did not came in GATE. Okay, so I will display this question on your screen and you can try doing this question. This is another question of, okay, so this is a stability constant question. So I will do this for you, or you can try doing this question and I will come with the solution in the next video. Okay, so one similar question I am doing, this came in net December 2016. Net December 16. So they are asking, they have given zinc plus 4 ammonia forms zinc ammonia complex plus 2 electrons whose E naught is minus 1.03 volt. Other reaction is the oxidation of zinc to zinc 2 plus and whose E naught is 0.763 volt. Now you have to find the formation constant of zinc ammonia complex. So that means formation constant means if zinc 2 plus and 4 ammonia molecules come together, they will form the zinc ammonia complex and K is the formation constant. That means you have to find the stability constant, you have to find the reaction constant or rate constant for this reaction. Now, if I can arrive at this equation using these two equations, that means this will be my net cell reaction and these two will be my 2 half electrodes. So let's try that. Now I need zinc 4NH3 and zinc 2 plus on the left side. 4NH3 I already have, so I will just simply write this reaction. Zinc plus 4NH3 will give me zinc NH3 2 plus and 2 electrons. Now I need zinc 2 plus, but I have zinc and I can get rid of this if I can write this in the reverse fashion. So I get zinc 2 plus 2 electrons giving me zinc. I have E naught left. So this is an oxidation occurring, so this is anode. This is reduction occurring, so this is my cathode. So I can get my E naught cell. That will be what? E naught cathode minus E naught anode, and that will give me what? Cathode is this one and that reduction potential is 0.763. So these are reduction potentials or oxidation potentials. We have to see that also. Okay, so this is an oxidation potential given. E naught cell for this reaction. Whenever we use the E naught cathode and E naught anode in these reactions, we always take the reduction potential. So if the reverse happens, this will become negative. So I would get minus 0.763. And the anode, again the anode they have given the oxidation potential, but I need the reduction potential, so that will be minus of positive 1.03. There was negative, so it has become positive now. So I get both are minus, so 3971, 1.793. Okay, so this was positive. I made a mistake. So that is positive, this becomes negative, and both change to 0.763 plus 1.03. And if you solve it, we will get here 7, 6, 2, 0, 0.267 volts. Now we have to find the formation constant. The relation of E cell with rate constant is what? E naught cell is equals to 0.0591 by n log k. The formation constant be kf. So let us find this. We would get 0.267 volts is equals to 0.0591 upon 2 and log kf. So if I take this here, I will get 2 7s are 4, 13 and 5, 0.534 upon 0.0591. This would give me log kf. So okay, we have to solve it completely. So 0.059 into 10 times would give me, so let us remove the points. we get here, and we get here. So we are left with 0, no 0, 534 by 59.1. 10 times of this will give me 590. Now, okay, so let us say so on doing 9 times we would get 531, so it will be 9 point something, and this is equals to log KSP. So that means KSP will be what? 10 power 9, which is my option number C. So these are the type of questions which come from solubility product, stability constant, formation constant, and before that we saw for the equilibrium